Okay, so let's see this another example. What I'm doing, I am on the github.com, right? So github.com is a web app. Okay, it has integrated auth, like I can do login with the Google. If I have my own account, then I can just directly username password, but I don't have a GitHub account. I will try to log in with the Google. So what it will do, it will give me the same consent screen. I will try to log in with my personal account. It will ask me, I think, because I already have account. Now the Google is asking me the consent. So when you say continue, this Google authorization server will give me the auth code, and this web app will exchange the access token with the auth code. Now, I don't know which email I'm using, but let me just see. Link account. Or it is asking some again two-factor authentication, because that two-factor authentication is enabled, and I don't have my phone nearby, so I will just cancel this for now. But this is how it happens. When you say continue, it will send a code, you will exchange the access token, and after that you actually give consent to the Google, but Google has given access token and I have created my account on the GitHub web app. Now I should be able to access my resources because I'm now logged in user on the GitHub. You can see any other app. Let's say I do login in the Google. Here it will take me to the Google authorization server. I already have a Google account, so I will say continue. It will redirect me to the man app because I am already signed in, and I'm able to access my account, right? So similar kind of platform exists. What this application has done, this application which I'm accessing, they have configured the social login using auth flow. For that, you need to go to the Google Developer Console, GitHub Developer Console, create the access keys and secret key, so that the Google and GitHub allows your application, so that your application users can use the Google and GitHub account to enter or to log in into your application. Another important thing is, because there are, when you talk about auth in depth, there are different flows, because there can be authentication auth using machine to machine, simple authorization code grant flow, password grant, implicit grant. These are the four flows, authorization flows which exist with auth. Okay, we will talk about one by one. Like when you have a web or mobile login, then you can just use the PKCE because it enables the extra security. Client credentials, when you want to have a inter-service communication, then you just use client credential flow, where you just share the client ID and secret ID from one service access the another service using that. Password grant, right? Because all the legacy apps using this password grant, implicit single page application, but this is also deprecated. Currently on all the web app or mobile app, you see authorization code grant flow, PKCE. This is the flow which we will talk about. So when you talk about Auth 2.0, these are the 4 different flows which exist in Auth, and you might end up using one of it. So let's talk about all these 4 different authorization flows in Auth 2.0. I will talk about what all I am using and what all are popular, right? So PKCE, this is whatever the demo I was showing, all are PKCE code grant flow, right? How it works, let's talk about it. So authorization code flow with PKCE, what happens, this is useful for the web application, mobile application, or maybe Electron web app or something, right? Use a code exchange that supports the refresh token. I have shown you in the diagram that authorization server sends the auth code, and in the exchange of auth code, we get the access token. That is a code exchange happens, right? So flow is app redirect user to authorization server. When you click on login with the Google, what happens is it is taking you to the Google authorization server. You enter your email and a password, and then it asks you for the consent. Then authorization server redirect you back with some code, right? The auth code, and the application exchange that auth code and gets the access token. This is the PKCE, the most popular, and this is what we see everywhere. Why PKC? Like public client mobile app can't store secrets safely. So PKC adds security on top of that by exchanging the auth code with the access token, right? We can see this flow in the diagram also. This is the typical PKC user. What user will say login with the Google. The client will redirect with the code challenge or with the login. You do the enter your username, password, and give consent. Right? Then authorization server will redirect you with some code. Now what you will do is you will exchange the code. The application will exchange the code with the access token. You get the access token, and now you start accessing the protected resource from the API server. The app API server. Let's say the Notion app. So Notion has its own API server, which will give us the document, but we are using login with the Google. So authorization server is from Google. They are validating our Google account, and we are giving consent to Google to share this information. So they are returning the code, and the client app is exchanging that code and getting the access token. So this is the security which the PKCE flow is adding. So second in the line is the client credential flow or authorization code flow. Second is yes. So this is like when two systems wants to access things, right? So what we do is, let's say one server want to access the data from another server. What we can provide is we can provide some kind of a client ID secret key to authorized servers. Then server application returns the access token. App uses token to call the data API. So it's not like some two app systems are just talking with some API key. No. First, you will pass the client ID and a client secret to the authorization server. Authorization server will validate and will return you the access token. Now your application will use that access token to call the APIs. Right? There is also a tiny diagram for the same. So this is machine to machine. Client will send a client ID and client secret to authorization server. Authorization server can be a third party. It will return you the access token. Now with the same access token, you will start accessing the API server. This happens when there is no client involved. That means we are machine to machine. Another machine will give us the access token in the exchange of the client ID and the client secret after validating it, right? So this happens when, let's say, I will give you a simple example. GitHub APIs, Google APIs. Let's say I want to access the YouTube API data. What I will write? I write a Node.js app. So that is also server-based application and YouTube APIs, right? So what I will doing? I will create a client ID and a secret from the Google Developer Console. I will call their SDK with the client ID and a secret. They will give me the access token, and with that access token, I will access the YouTube API data, right? So this is simple machine to machine, because to access the machine, I need access token, and for access token, I need to have a client ID and a client secret. So similarly for the Twitter APIs, let's say if you want to do some data mining on the Twitter data, you can use Twitter Developer Console. You will create your app. You will get a client ID and client secret. Using that, you will get access token. And using that access token, you will access the Twitter APIs to fetch the data, which is not public. So this is the machine to machine. Another is a legacy. Okay, you provide username, password, send credential to authorization server. Authorization server will give you the access token, and access token you will use to access the APIs, right? This is not typically auth flow. This is the legacy and deprecated. What we are doing is let's say there is an auth service, right? Auth service is giving us the token in the exchange of username, password, and then we are using that access token to access our own internal APIs. Okay, so these are the typical flows, not important. You just need to focus on the PKCE flow. That is more important for the auth flows. Now in the next video, let's talk about all the building blocks of auth. Okay, so before diving deep into the code implementation and check end-to-end how auth we can implement with our Express app, NestJS app, let's understand the terminologies. 4 key roles in auth flow: resource owner, the user who owns the data, the client, the app which is requesting access on behalf of the user, like a Spotify, Slack, Notion, Postman. Authorization server, you are doing a login with the Google, then authorization server is Google. You are doing login with the GitHub, then authorization server is GitHub. Resource server, the Google Calendar API, GitHub APIs, Twitter APIs, the protected data. For that, you need to be logged in or have an access token to access to. So Auth 2.0 flow is very simplified. User initiate login, user redirect to the authorization server, login with the Google, user authenticate, authorization server grants the permissions, authorization server redirect with the auth code, the client app, the Notion or calendar app exchange the code with the access token. Now client get the access token, they can access the protected resource data. So what is the access token? Access token is, there are three type of token: access token, ID token, and there is one more: access token, ID token, refresh token. We will talk about these and the uses. For first, access token. Access token is something which we will pass to the API server in the headers, in the authorizations header, so that the API server will validate the access token and will enable us, will let us to access the API data, the protected data. Refresh token, it's a long-lived token stored securely, and we can pass the refresh token to get the access token in the exchange. The scopes, the permission requested by client to access the specific resource, like email, profile, calendar.read only. The consent screen, which you see when you click on login to the Google or GitHub, they present you the screen. Do you want to share the information? Now these grant types: authorization code grant, which is the default PKCE. Authorization code will be granted by the resource server, and in the exchange of it, we will get the access token. Client credential, password, implicit device code, right? So all these things we will do. And yeah, so we will talk about even the basic, we will debug the network tab also, like how all these things are configured with the auth also. So let's talk about the practical implementation, what all things you need to do. So the first thing, let's say I'm a developer. First, I will go to this Google Developer Console. This is the first thing I will do is, and I will register my application. Let's say my application is, this is my application name, and I'm a developer. I will go to the Google Developer Console, and what I will do first thing is, I will register my application there. When you register, you will get a client ID, client secret, and you also need to specify callback URL, and on which port, the domain where you will be running your application, either localhost for testing or the domain. Why we need that? Because we are building a Notion app. We want user to, and on this application, you will provide one button, login with the Google. Right, so what happens? Why we need all this information? Because we want to enable the Google sign-in with our application. Otherwise, how Google will identify that, when you click on to this login with Google, I need to present a login screen. I need to create an application on Google Developer Console, right? That application Google will give us the client ID, which I need to configure in the client app, client ID, client secret, callback URL. Because once the Google says, I have validated the user and I have the authorization code, I need to go to the client app. So for that, I need to provide a callback URL and the domain using which I will be testing or deploying this application, because then Google will allow for this client ID for that domain only. Nobody can just use a random domain to use this client ID. Client secret we will keep secret, and the callback URL we will specify. Once you have done authenticated, redirect to this URL so that my client or my server can access that code and can return an access token, can get an access token. So these are the important things which we need to perform as a step 1. Go to the developer console, register your application, get client ID, client secret, registered a callback URL, registered a allowed logout URL, allowed domains, all these things. Then you will write your code and put the client ID, client secret in your code, so that when user clicks on to the login with the Google, we are able to communicate to the authorization server, which is a Google, which can be a Google, GitHub, based on where you have created your application. So that is a step one. Let's take a look onto that. Okay, so you can go to the Google Developer Console, inside this API services and credentials. So inside credentials, we can create a Auth client ID. What we are doing, we are kind of creating a web app, right? Just create a, let's say web app name is KTS Sharma V2 2025. Okay, so here we need to add the authorized URI, JavaScript origin. I will just add a local host for now. And authorization redirect URI. Contain a domain. And here URI HTTP localhost, because we are going to test this application. I think it should be auth Google callback. I will check. I mean, for now I'm just registering one application. So here it gives me client secret and client ID, right? I will just copy them and I will start using them. So this is the step one. You should go to the Google Developer Console, create an application. Now we need to configure this application in our Node.js backend, Express app and the NestJS application, so that we can allow app users, because this is the app we are creating, TKS V2 2025, so that this app can allow users to log in with the Google, Facebook, Twitter, all these things.